Chapter 3, practice work. Here we go. Question 1, what's the square of 7? Square of 7 means 7 squared, or 7 times 7, 49. Square root of 16. I mean, you do that in a calculator, or you know that's a perfect square. We know that 4 times 4 equals 16. B. 3, which number is not a perfect square? 49 is 7 squared, 64 is 8 squared, 81 is 9 squared, 86 is not a perfect square. D. What's the prime factorization of 36? Show your work. Okay, over on the side here, 36. Any of the two factors multiplied together get 36. I'm just going to go with 6 times 6. How about that? 6 is not a prime, so then I can go 2 times 3, which is 2 times 3. Both of those are prime. So there's my prime factorization. So I find that 2 2s and 2 3s. A. Square has an area of 196, so again, draw a picture of that. 196 in there. So to find the side length on a square, we can square root that. Square root of 196. One of our perfect squares, which we know is 14 centimeters on each side. 14 squared is 196, so B. Okay, number 6. Which set of side lengths belong to a right triangle? So we're going to use the Pythagorean relationship here. Show your work. So let's go with A. Already can tell that that's not true. So it's 153 does not equal 256, so no. Okay, for B, add those together, they do not equal 121. Okay, that's 52, no. C, is 100, so that one is our right triangle, C. Determine the missing length. So this is a leg. We know the hypotenuse. So our formula is going to be, we'll call this one A, B, and C. So I'm going to do B squared, which is the unknown, is C squared, subtract A squared. I got to square root that to find the length of that side, which is 8. D. All right, remember that relationship. The squares of the two legs equal when it's a right triangle. So they got the signal here. We know that these two have to equal this. So in reality, we just substitute this leg area from this leg hypotenuse area, and it gives us this one. So
100 subtract 64 equals
36. C. Okay, on this one, here's our triangle. Determine the length of the hypotenuse. So this is our unknown. So that's our C. Okay, so C squared equals A squared plus B squared. And then add those together. I'm going to square root that. So then that's C. 10. Let's just state the Pythagorean relationship. So remember, if this was CAB, okay, these two equal this one squared. So it'd be S squared plus R squared equals T squared. So it equals T squared. This one has equals that. No, no, this is the only one that can work. D. The value of square root of 85 is between which two numbers? Well, our perfect square on the left is 81, which is 9. Square root is 9. Perfect square on the other end is 100, which the square root is 10. So it's in between 9 and 10, which is a 12. What's the sum of these numbers? So we're just going to add this.
So we got 3 plus the square root of 16 is 4, plus 9, plus the square root of 9 is 3, plus the square root of 121 is 11, plus 7. So
add those together. 9 plus 11 is 20.
7 and 3 is 10, and then that's another 7. So
looks like it's 37. B. Which of the following whole numbers has a square root between 5 and 6? So remember, squared 5 is 25, and then 6 is 36. So those squared is in there. 27 would fit in here. 37, no. 44, no. And 56, no. So A, 27. What's the approximate side length of this square? Okay, so all we got to do on this one, round to the nearest tenth. I know the area, and it's a square, so all I have to do is square root that 150.
150 square root. Said round to tenth.
12.2. 12.2 is A. The length of the hypotenuse to the nearest meter is, so show all your work. So again, A squared. Five. Not one of my perfect squares that I memorized. 324 is 325. 18.0. So D. Determine the length of the missing side. So we're going to find a side this time. We know the hypotenuse. Round your answer to the nearest tenth. Show all your work. Okay, so again, the formula is... We'll double check and verify that. 256 subtract 25, 231. B squared equals 231. I got to square root both of those. B equals, 231 square root, 15.2. 15.2, so it's B. All right, Linda rides her bike 200 to the store, 220, and then she rides 280 to a friend's house, and then she can cut across the field back. So we're trying to find the hypotenuse. Round your answer to the nearest tenth of a meter. Show all your work. I mean, it's going to be one of these answers. So we're adding those together to get C squared. To get just C, hit the square root button. 356.1, which would be D. Okay, and then we got, and that's 25 meters tall. Place 500 apart. So up here, then you got another pole. Okay, this is 500 meters. What distance from the base of one pole to the top? So again, we're just got a triangle now. We want to know the hypotenuse. Round to the nearest meter. Show all your work. A squared plus B squared. Add those together, you get 250,625 equals C squared. And then you got to square root those. Nearest meter. Meters. Okay, find the missing length. Okay, this one's crafty. We're going to find this one first because we know two of this triangle and we only know one of this triangle. So we know the hypotenuse and we know B. Okay, I'm going to square root both of those. So A is 6 centimeters. Now for this triangle, I know what two of them are. So now I can do that, square root that. 52 square root 7.2. So E is going to equal 7.2 centimeters. By default, do one decimal place if there's decimals. Okay, so A is 6 centimeters and E is 7.2. Two cars are stopped facing each other on opposite sides of the road. Okay, let's just draw this. Okay, each car then drives for 8 kilometers, stops, turns right, then continues to drive for 6 more kilometers. Use a diagram to show the situation. Determine the distances between the two cars. Show all work. Wants to know the distance from here. The car's here now and the car's here. How far is that? So we're just going to find this one and multiply it by 2. Okay, which is C equals 10. So one of these is 10. So two of these is, right, 20 kilometers. Estimate the square root of the following numbers. Okay, show your work. One decimal place answer. Okay, so again, we put the 128 in the middle. Perfect squares on either side. So on this side, it's going to be 121, which is square root of 11. And then 144, square root of 12. So my answer, whole number is going to be 11, because it's going to be in between here, 11 point something. The difference between these two is 7 over 2 times the whole number is 22. Okay, now if I do my little crafty here to make it an easier one, I'm going to make that 21. Now I can reduce this by dividing by 7, divide by 7. It's going to give me 1/3. And we know the benchmark, that's 0.3 repeated. So I'm going to say 11.3. Now if I was to double check and make sure that I'm on track, 128 square root, 11.3. There we go. Okay, again, 72 is in the middle. Square root on this side is going to be 64, which is 8. On the left side is going to be 81, which is 9. So it's going to be 8 something. Difference between these two is going to be 8, and then double this is 16. This one's really easy. 8.5. Let's try that out. 72 square root button, 8.48, which rounds to 8.5. Prove that 64 is a perfect square without your calculator. Make sure to explain why it's a perfect square. Show your work. Okay, so we're just going to do prime factorization. 64. Okay, let's say it's 2 and 32 to make it easy. 2 is a prime. 32, I'm going to go 4 times 8. Okay, neither of those are prime. 2 times 2, boom. Now I'm going to say that this is 2 times 4. Got to keep going. 4 is 2 times 2. Now we're in primes. Bring down that 2. Bring down this 2. Bring down this 2. And then bring down our final 2. So now we know it's a perfect square. Why? Because if we count these prime factors, 1, 2, 3, 4, 5, 6, we have an even number of the same prime factor. That makes it a perfect square. Here we go.